So 3.3. Just write out the problem. Or not the problem, but you know what I mean. Chapter 3, problem 3. Stack of plates. .clj. And okay. So stack of plates. It's a long description, so sorry. Imagine a literal stack of plates. If the plates get too high, it might topple. Therefore, in real life, we would likely start a new stack when the previous stack exceeds some threshold. Implement a data structure set of stacks that mimics this. A set of stacks should be composed of several stacks and should create a new stack once the previous one exceeds capacity. Set of stacks push, set of stacks pop should behave identically to a single stack. That is, pop should return the same value as it would if there were just a single stack. Follow-up is implement a function pop at int index, which performs a pop operation on a specific substack. I assume they also mean that pop at should pop in constant time, just like a normal stack. Actually, that's complicated because now we have to kind of ask the question, like if they didn't specify what do you do with push then. If somebody's popped something off a specific stack that is the not the does that mean you should then add the value onto the minimally pop stack, or does that mean you should pop off of still the latest, or you should push if somebody pops something off the first stack and you have two stacks, should you then, if somebody then pushes something, push onto the first stack, or should you push onto the latest stack? Okay. So anyway. All right. Takes, nothing, and returns. I think it's basically just a stack of stacks, right? I mean, that's what you, I think, want is a stack of stacks. And so your empty now is a bit different actually, because now your empty is saying rather than calling just a stack, I'm going to call it an S stack. Anyway, but you're saying your S stack should just be equivalent to if your S stack is equal to that, then you're done. That means you are empty. Stack peak. Yeah, I'm not. Yeah, I guess that should go to the S stack peak, right? I don't think we have a value anymore. So the difference is, one thing is we're not putting maps in here anymore. Now we are just putting values in directly. But, yeah, anyway. So the S stack, this determines that you're empty. This is your peak value, which is you take the S stack, and then you peak at the last item in the first stack, right? And then you peak at the last item in this stack, So what about stack min? Oh, that doesn't exist. Yeah, cool. What about stack pop? I don't like calling these things. I'm going to call them plates, you know. Of course, it's... How about a plate stack? All right, it's plate stacks. I'll call it a stack, okay. Okay, what about pop? So all we need to get is pop and push. So pop is a little more difficult, but not a whole lot. Oh, we do need to modify this, don't we? S stack. Actually, yeah, we just need to assert that you're not empty, really. Right? I should have done that on the last time. I didn't really notice that. Assert that you're not empty. Yeah, I think that makes sense. Do that here. And okay. So, if you're not empty, that's cool. All right, let's talk about popping off. Which one's easier, popping or pushing? I think they're both kind of a little bit convoluted, but not terrible. So, popping, you are going to pop first off your own stack, and then if your own stack is empty, you're going to pop off the previous stack, and you're going to keep doing that. Well, we know that you're not empty, so we know you have something to pop, right? Okay. So I think it may just be update SS stack. We're gonna pop. There's no way for me to do this, is there? Okay. I want to update the peak item. So I guess I want to pass a function that I'm going to this peak the real closure peak, not the stack peak. No, I really want to... Well, I guess that's the issue, right? We have to figure out whether I need to drop the container or not. So, okay, let's get the peak of last peak stack, right? We're just going to get the peak of the SS stack, right? So that's the last stack in our stack of stacks, you know? And looking at that, we can say when, or if peak stack is empty, and by that I do mean actual closure empty, normal, then that means we're not going to pop off this one. We're actually going to pop off the other one. Wait, should this ever happen? Should there ever be the case that you have a stack? No. I feel like this shouldn't be the case. Pop should always just be able to pop the peaked item stack. I do wish there was a way to access that, but so we have the peak stack. I'm going to say peaked stack. And we're going to Okay, we're going to take the original stack. We're going to conj onto it after popping off of it, right? We're gonna pop the current head off the P stack, which is this, right? And then we're going to conj onto it the modified peak stack, which is going to be the conj of the peak stack with oh, I'm doing the backwards, aren't I? I don't mean I'm trying to do the push, not the. Okay, which is going to be the pop of the peak stack. I think that's true. I think that's basically it, and it's basically it because and so we can really just say SS stack peak pop, right? And get rid of this. And I think that's it, because basically what we are saying here is, hey, we know A, that we're not the empty stack, right? Because we got past this point. And B, so basically, and the other thing that we're sort of affirming here is that there is no, we're also sort of saying here is that the condition that occurs in the empty stack occurs nowhere else, you know? That is to say that there is no case, like you never do this, basically. Let's say the limit was 5, right? And you did 1, 2, 3, 4, 5. This is not what occurs, right? There is no next stack until we have a value to put onto it. So this is what putting 5 items on the stack does. When you put, and this is what the data structure would be. When you put 6 items on, then it'll look like this, you know? When you pop the 6th item off, then it'll look like this. This does not actually do that, though, does it? So we do need to make sure that we, it's actually, this is the one we need to, right? So we're going to pop the 1 off, but if empty new last stack, then we're basically, we just are going to just pop the S stack, right? We're done. But if that's not the case, we're going to conj onto also the pop of the stack. The new last stack, right? This will ensure that when you pop, if you had to pop off, if you pop the current stack to the point that it's empty, it will then go from this looking state to this looking state. Let's not be editing here. This is not a good. Does that what happens if you pop? You can't ever be here, right? But what happens if I pop from 1 from this? I mean, ideally, I'd want to pop into this. Is that what happens? Let's see. So it would look at this. Where am I? I'm here. It would look at this. It would say, okay, this. Then I do the peak, which is going to be the vector 1. Then I do the pop, which pops the 1 off the vector 1. But then I do the empty. And my new last stack is empty, so it's going to pop the S stack, which actually is not what I want in the specific case that we're dealing with the empty stack. Huh, interesting. So where should I handle that? I could just handle it on the outside and say, look, if you're you know, of this form, then just transform it into this, you know. Or we could just do a con again, basically. And so I'm going to say if and of S stack, the count is equal to 1. And, oh my gosh, that's wrong. Okay. Count of count of the peak of S stack is also equal to 1. Holy crap, that just looks terrible. Alright, just a second. If S stack count is equal to 1, and if S stack peak count is equal to 1, then we know we got the weird condition where rather than doing what you would think you would want to do, we want to put us back into basically this state, right? So we're just going to say, just return this. You know, otherwise, if you're empty, pop the new last stack. And so all you're doing is just popping S stack. That is not a thing. Otherwise, pop the S stack and put the new last stack and conj the new last stack onto the end of it. So that will mean that we'll always, when the stack is fully emptied, it'll always go back to this state, basically. Which is nice because then we can just reason about it as if this is always the one and only terminal. Because otherwise it's like a confusion about whether this is the 0th case or this is the 0th case. And I'm just going to stick with that. Okay, so that's stack pop. Let's look at stack push now. Well, that one is more complicated than I'd like. I hope the other one's maybe easier. Stack push. So we're taking a stack on an item. So what we're basically saying is, and I guess we have a capacity too implicit, right? Def capacity. Let's make it 5, you know? Actually, let's make it 2. Let's make it 3. Okay. So, oops. We're going to push onto our stack, into our S stack. And okay, we're going to push onto our S stack. And the S stack is going to... Alright, sorry, stop, collect your thoughts. Okay, yeah. The S stack is going to... I guess the big question is, can we push onto the current stack or do we need to push onto a future stack? And so I guess that's all we need to ask is, I guess we know whether we're going to push onto a future stack at the very beginning, because we just say over capacity, right? Or I guess we could just say new stack, right? We're just going to say is the S stack peak count equal to the capacity, right? if it is equal to the capacity, then we can't push onto the current stack, and so we need to push onto a new stack. So that feels like we don't really need that. We can just say if that's the case, then let's do one thing, and otherwise let's do the other thing. So if I am at capacity, then we need to push onto a new stack. And so it's pretty simple, I think. I think we just say conj onto S stack. We're going to conj a new stack of the form V, right? But if we were not at capacity, I really wish there was an update or an update in function I could use. I mean, I guess I can. I can use update S stack with an index position of the S stack count, right? Let's see, do I want a decrement one? Yes, I believe, right? And what I want to do, I want to conj onto, I want to conj V onto that. I might use that to make this a little bit better, maybe. No, actually, I don't think that's that bad. Okay. How many places am I using new last stack? Okay, never. Actually, we didn't need new last stack in the first flow. New last stack, pop the S stack. Okay. That makes sense to me. You're saying that the new last stack is empty when you pop the value off of it. Then actually you should just drop the whole new last stack. Finally, if you're saying if the new last stack is, if we got through all of this, the new last stack is fine, and we're just going to pop onto the stack. We're going to pop the value, the old last stack effectively off the stack, and we're going to pop the new last stack on. And this one just says if the count is 1 and the peak is 1, and the vector, the stack of the stack is also 1, then we're in that weird case where let's just sort of back into this. Alright, so this pushes onto the stack in, I think, a correct way. Alrighty, let's see what we got. Alright, so 0 stack is equal to stack of plates. Right, okay. The stack 1 is, we're just going to stack push 1 onto 0 stack. It's pretty much the same thing, actually. I guess all of these are the same, right? This is, yeah, they all still work. They're the same interface, basically. Okay, cool. This should still be true. Okay. So for the 0 stack, or for the 1 stack, yeah, this should be 1, this should be 1, this should be, let's call it 0 stack somewhere. No, it's not, because, well, yeah, I guess it should be 0 stack, right? We don't have this anymore. Now this kind of ends up testing the peak and the pop and the whatever, but let's think about it. Yeah, so I think these should all still be true, right? They're the same test, really. Which shouldn't be true is what shouldn't be true is which shouldn't be true. I don't know, I think everything is pretty much exactly the same. It behaves as it's a perfectly normal stack. It's just that in reality it's splitting at fives. Or threes, or whatever they are. Let's see what we see. Chapter 3, problem 3, okay. Stack min. Yes, you're right, there is no stack min. Again, same thing. Wow, really? Okay. It seems pretty good, doesn't it? I mean, all right. Let's try to do the additional one, which is follow up. Implement a function pop at in index, which performs a pop operation on a specific substack. That shouldn't be too hard. Def and maybe pop at, right? I guess let's put a next together pop. And that takes an S stack and also takes an index position. Oh, actually, well, yeah, it takes an index position. And then it's going to return a new stack with a specific item popped out. So it kind of just circumvents the whole thing. It does suck that we got popping at on the empty stack still has to be handled in the same way. Golly, is there any way I can just use the previous stack pop? I don't want it to rewrite all this logic. It sucks. I feel like maybe we can update yeah. Actually, pop-at does introduce a problem for using a stack, right? Because pop-at, if you pop at the empty stack, you now kind of want to clear out that stack. If you see what I'm actually, do you? No, you don't. Pop-at is just special in that. Oh, that sucks. Yeah. Now we can't have that invariant that says there's never, that weird empty. There's never an empty stack other than in the base case. I can just have pop-ats just pop off a specific stack index. That's fine. But then, if I do that, I kind of have to. I have to kind of shift the remaining stacks left, right? Is there any way to get around that? Well, yeah, the way to really get around this would have been not to write it in a stack as this at all. Just use a closure map. Let's think about that. If I used a closure map, basically, and I'm basically saying for every item so basically, in order to push an item onto the map, I say the size of the map, and then I ask for the size of the map, and let's say the item map currently the map slash stack. It's a map, but we're using it as a stack. It contains 5 items. The size will be 5, and so I'll add a key called 5, which currently there's a key 0 through 4. I'll add the key 5, and then I'll add the value at 5. Then I also just have to record, or I don't have to record anything because I can just always ask what the size of the map is. But when I want to pop off the stack, I will pop off 5. You know, I will ask for the size of the map, and whatever the size is, that's the item. I'll decrement that number, and that's the item I want to pop off. You know, so that works. But then can I also? I couldn't. It'd be hard to implement this. Yeah, I'm just not 100% sure what they really would want the behavior to be for this pop at. S stack I. I'm going to do correctness, but it is a linear cost in certain cases. So I'm going to say take. So if you say I assume you mean index position. Yeah, okay. And so 0 would be the first stack. Yeah. So you might say take I from S stack, or actually what you can actually say is subvec S stack I, right? And then on that substack, I think you can call stack pop, right? Right. And then I think on the remainder, that after the subvec, I think this does 0 to I, or does it start at I? I gotta look. What does subvec do? Subvec. This is the start index, and this is the indexes. Oh, so it actually is from start. So I think we actually want to subvec from 0 to I, right? Shit. Well, that means you could be popping the empty stack, which is going to be, which we want to be this. But if you specify 0, if you specify index 0, it'll think you don't want to pop anything. Wait a minute. No, it's not. I'm being confused. So I say, what was I doing? I say subvec of the S stack from 0 to I. But subvec of S stack of 0 to 0 is going to be nothing. It's going to be the empty stack, and then you're not going to be able to pop off that, I believe. Huh. I don't believe you're going to be able to pop off that. Why is that? Why is that off by 1? I this just doesn't feel right, because you should be able to reach directly into the stack, directly into the thing. Well, yes, but the problem is you may end up with the case where you have an empty stack, an empty substack in your S stack, right? And so we have to handle that. And how can we generically handle it? Well, I can grab this, which this gives me from 0 to 0. That'll just give me the empty vector, which isn't probably what we want. If I want the thing at this position, I think I want maybe the increment of it, 0 to 1. Now I always, at minimum, will have 1 element in here, and may have more. Yeah, so we're starting at 0 inclusive, 0 to end, not including the end. Defaults to count a vector. That makes sense. Okay, yeah, so that's that. And then I'm just going to pass that to stack pop, which is going to pass
which is going to call stack pop on it as if that was the entirety of the stack, but it's in fact not. In fact, we are going to take the rest of this from I, or of S stack, onward, right? And I think this has a linear cost for the remainder, basically. Which isn't great, but hey, you're doing a weird operation on what was previously a stack. And and it also, well, it sucks because in most, I mean, we could make this better in that this is just you're going to pay the linear cost of adding these end items onto the existing stack that you grabbed every single time. But like realistically, you only need to pay that actual cost when you actually pop something. You only need to pay the actual like I'm reducing the size of S stack down when you actually are popping a substack such that it's empty, which is rare, right? Most of the time it's not empty. Most of the time it's you're just popping the substack. So I'm forcing you to pay a linear cost. I mean, we could have two conditional branches here. One for, I've looked at the size of the substack, and it's greater than, it's not one basically, which means that, we are going to be able to pop off this thing without it actually being a modification. Or two, I've looked at the substack, and at that location, and it is one, unfortunately. And so when we pop off, we're going to have to do this whole thing, right? I guess let's give it a shot, But if S stack has a at index position I, right, is has a count equal to 1, right? Then we got a problem. We got to go through this entire like linear shifting thing, right? This is an example where maybe you could, if you were doing the mutable thing, right, you can just, rather than having to shift all the remainders, you could just point the previous stack to the next stack, right? So this would have an advantage, performance-wise. Anyhow, on the other hand, that's true, but on the other hand, they can't do this, which I can do, right? I mean, my stack is efficient to array access. It's constant time access, as opposed to, which is not really a big deal when you're only talking about the top. If you're talking about the top of a linked list or constant time to array access, and that's equivalently expensive. But I'm actually able to reach into any element in the stack, or any substack in the S stack, and just pull out and just deal with that element directly. Rather than having to run through a linked list to find that element. So I don't know. Yeah. But so yeah, this is my one if statement, which is like the complicated one, and this is the simpler one where, oh well, cool, it's not 1, which means it should never be 0, right? Oh, that's a lie. It can be 0 for this stupid freaking reason. Let's try that. I mean, maybe. Yeah, if it's zero, either 0 because of this stupid reason, or 1 because of the normal reason, then actually no. If it's 0 and you tried to pop it, yeah, if it's 0, so I think we should just have the same assertion here, right? It feels like we shouldn't need it because no, because there's paths that go through here that don't actually pop it, right? First of all, we're just going to assert that you're not empty, right? So we don't have to worry about the 0th case. We do have to worry about the one case, right? Where you have one item left on a substack. Because that means we're going to have to do some crazy stuff. But if you're not doing either of those things, then we can probably just call sstack, and we can say, sorry, update in sstack at position I, and let's just pop one item off of that, right? Because we know that you're not 1, and we know that you're not 0, right? Because that should never happen, other than the 0th case, which we checked for, you know? So we know you're not 1, and we're going to pop yeah, okay. We're going to pop just at that location that sstack. And so that may take it to 1, 2, 3 or higher in terms of the size of that stack. But just return sstack. This guy says, does it really need to be this complicated for, like, we're just popping an item off? Well, it needs to be this complicated because we may need to handle this case, right? If you come in as this and asked to pop at index position 0, we would like to enter into this world where we can handle that, correctly. Similarly, if you weren't that, but you were instead this, right? Which from this guy's point of view, the new last stack is going to be the empty list. So instead, he's just going to pop off the last guy. So we want to handle that correctly. And then finally, if you're neither of those things, you're like this, we just want to pop the stack and then put in the new last stack, which would just end up making it look like this. And so that's the substack. But then it turns out we did a weird thing, and we actually are going to conj the rest of the things back on there. I think that makes some sense. All right, let's see. Did we test any of that, though? Yeah, we haven't tested pop at all. Test the pop at. Okay. All right, so I think I'm just going to write out some Okay. So what should this end up? I'm just going to write down what I think it should end up being, right? It should be ultimately a what was this? Well, I just copied it, so what does it matter? But if you put ascending things into a stack, then you should end up with a stack that has 5, 4, 3, 2, 1, right? Okay. When you pop things off of it. We aren't going to pop things off. I just want to see what the stack looks like. I'm going to look at the stack directly, right? Yeah, let's just look at the stack directly. I think it should be this, right? And I think this guy should implementation. Okay, so I think this guy should look like this. This guy should look like this. Does it seem right? Stack descending from root. Yeah, okay. And this guy should look like this. I guess it's not terribly complicated, but... stack equal. No sorry, Bab. So, evidently my intuition is not right about this. Stack ascending from root. Okay, if you're ascending from root, then we're pushing these items one at a time, which means the lowest... Yeah, you're right. Okay. So I think it's actually the way around. Okay, cool. What if your stack descending? Alright, so I think we can get it to pass, but then let's actually try testing the pop at. And so test pop at for test pop at. Alright. So if we pop at oh, we should have called it stack pop at, shouldn't we? Just to make it consistent with its buddies. If we pop at, then and we pass in, let's say 0, right? What should we get? We should get 1, 2, 4, 5, right? Similarly, if we pop at okay, let's try something out here. I'm going to stack des from root, right? I'm going to just stack top the first one, right? But I'm then going to also stack pop at the second one. I'm going to pass in the first L stack. That should return 5, 4, 3, and that's it. Okay. What about taking the last item off a stack? That should handle this. Wait, what are the two cases we kind of looked at here? So this one, the first is on the stack pop at should go through just this normal path, right? Which is pretty simple. Yeah. The second one is a bit more complicated and is also the linear cost one. In the event that you've actually popped off an item that yeah, you've actually popped off an item that is now empty, you know. Okay. I don't. Okay, I'll talk about that later. But and is there anything we want to check here? Yeah, we want to pop off the last item. Stack pop at this at element 0, right, this should return the empty stack. And it should do so through this code path, because we were, technically this was true. Actually, wait, I don't think it would even do it, because, no, it will do it, but we're gonna get the subvec, which is 0 to 1, which is just exact same, it's a literal copy of it. And then we're gonna stack pop, but we're gonna hit this case where we do this weird thing. And so what we end up is this. This is actually what I meant. Or actually, I mean is the 0 stack. And what we're going to pass in is the stack EQ. No, we're not going to pass any. I'm going to just write it directly right here in line. Right? You know, actually, putting these as symbols kind of makes sense, but I actually feel it might be clearer to just put the actual values in there so we can like do them all like this, right? That maybe actually makes just it easier, because now you don't have to read up to figure out what you're doing. Okay, so failure. Although we actually did pass 11. So 5, 4, 3, 5. Well, we had one failure and one error, I guess. Yeah, okay. So pop after 5, 4, 3 and pop an error on this one. So that's not a terrible surprise. This is a pretty unique situation. Cannot call stack pop at with one argument. Oh, well, that may just be stack pop at. Well, it looks like I actually accidentally called it with 3 arguments, but who's counting? So 2 failures. Okay, well, that's something. Ooh, and that's very wrong, you know. Weird. But so I'm saying it should be 5, 4, 3, and what you're saying you're going to give me is 5, 4, 3, and 2. Well, so first of all, you're just basically giving me the identity function. Right, that's what I passed in, right? Well, kind of. Again, this is why, actually, I think for this one especially, too, it's clear just to put it in directly, right? 5, 4, 3, and 2 is what we wanted input. So now we don't have to do the weird stuff to manipulate it into the right way. Okay. Alright. 5, 4, 3. So I passed in 5, 4, 3, and 2, and said I wanted to pop at the item on 1, right? This one, which is it's just fundamentally equivalent to actually popping at, just calling pop, right? But it didn't work, and what it gave me instead was, well, you wanted 5, 4, 3 to be equal to 5, 4, 3, and 2. So you kind of just returned exactly what I passed you, which doesn't make any sense to me, but. This guy did something very weird where he added 1 onto the end somehow. You know, I guess one thing we actually can do if I is equal to the alright, help me out here. If SS stack count decrement is equal to I, right? Because it's zero-based index, right? So if you're talking about the last stack anyway, then I don't think it really matters, so I'm not going to actually do that. Okay, so 543, stack pop 5432 just doesn't do anything in terms of what I would expect it to do. Doesn't do anything in terms of what I would expect it to do. Okay. So what does that tell me? Well, what if it's wrong and it's saying it's false when it should be true? SS stack inth I. So I is zero base, so that should work. Then you take the count on that and you say, is it equal to 1? Okay, if it is equal to 1, we're doing the long operation with expense, and if it's not equal to 1, then all we're doing is update on SS stack I pop. And we said we're popping on 1, right? So that should be this one, right? So this should return the 2, the count. We take the count of it, which is 1, and we say it's equal to 1. So it should be going into this path. On the flip side, this other one that does work correctly is the 1, 2, 3, right? Then we're just doing the update, right? Which is comparatively simpler. But I am curious why this doesn't work. Into stack pop subvec SS stack from 0 inclusive to 0, let's say in this case. From 0 inclusive to 0 to 1. So that should return the whole root stack. We did increment this, though. So actually we are including this one. From 0 to, we passed in 0, but it's actually going to pass in 1. So it is going to take the subvec, which should just be, in our case, it should just be processing on 5, 4, 3 at this point on this stack pop stuff. Does that feel right? Well, no, that would be for the 0 one. It would be passing on 5, 4, 3. Right? That's actually what it's seeing because of the subvec. Lies. Anyway, but index position 1. Stack pop at subvec SS stack Y. 5, 4, 3, 2. If you pass in 1, I'm going to think you mean this element position, right? I'm going to say, okay, this is 1, so I'm going to go into this whole path. I'm going to say, let's call stack pop on the whole thing. I think I feel like this should cause no change at all. It should be from 0 to 2, which should include the entire subvector. And so now I'm just saying stack pop on the subvector. But then similarly, I'm saying maybe I need to increment this one too, because I incremented that one. I went from 0 to 2, but then I said start me from 1. See, I think I need to start from 2 in terms of what I add onto the end. There we go. Okay, I'm sufficiently. So I thought it was pretty interesting actually to realize just how wrong I was on the last one when we looked at the hints. Let's look at the hints just to. I think we have something that works, but let's look at the hints. So the hints are number 64 and number 81. Okay, so number 64. The hint is. The hint is you will need to keep track of the size of each substack. Sorry. When one stack is full, you may need to create a new stack. Oh, that's kind of obvious, but okay. 81. Popping an element at a specific subtask will mean that some stacks aren't at full capacity. Is this an issue? There's no right answer, but you should think about how to handle this. Well, I handled it at a linear cost. I handle it at a linear cost whenever the stack needs to be removed because it's empty. It's possible. I don't think it's possible other than I can't think of an operation that would let me. I mean, other than a real mutable link list that would let me link the previous stack to the next stack without shifting the remainder over. Let's run through that test too, because that's actually the big test too. Is there as well as okay. So what if we're in sort of this situation where 5, 4, 3, 2, and 1, right? This should actually result in 5, 4, 3, 1, I think, right? Because we deleted the 1 at index position 2, and so now we should get the remainder conged onto the end. And it worked, cool. Okay, so yeah, I think this is actually a pretty decent solution. The only thing that has some issue is that, if you pop at a stack such that that substack becomes empty, then there is a linear cost to slide the remaining stacks into the existing stack. I should have mentioned, I didn't really say this, but subvec is actually a constant cost operation, right? So subvecing a vector is a constant cost operation. But into, right, this subvec right here is also a constant cost operation, but putting the values in the from this sequence into this vector is a linear operation whose expense is the number of items in this subvec right here, right? And so, so like intuitively, you might think that so you might intuit from that if you pop off the beginning of the stack, right, the very latest one, that's a more expensive operation. If you pop at from the beginning of the stack or the S stack, that's a more expensive operation than popping at from the end of the S stack, right? Because at the very end, you don't have any remaining things, so it actually is just a linear operation. So. Anyway, I think that's pretty decent for this one. So it feels a little better after that incredible screw up on the stack, man. But I guess it's all learning. Okay, whoops, Alt W. All right, stack of plates. Oh, okay. Oh crap! Did I not name the last one correct? All right. Well, unfortunately. Golly, Steven, come on. It should have been 3-2. Oh well. 3-3. This is the problem with actually. So the reason I can't go back and just amend things, right, is because I need to write another little thing that lets me amend things without changing the commit times at all, which I'm just not sure if amend is going to do that, basically. I think it may change the commit time, but not the author time, or something goofy, complicated. I'm not really sure, right? And so I just don't want to do it. And the reason for that is because I wrote another script at, well, anyway, I wrote it, that it's open source, so you can find it. that will split up your videos by their commits, right? By the commits in a project, right? And so I don't want to modify the author dates because then the videos won't split correctly. So Star's just stuck with this, but anyhow. Stack of plates, problem 3.3 of cracking the coding interview. 6. All right, looks